Alright, today we're going to be doing area and volume, more so volume than area, but I'm going ahead and giving you the definition of area because we'll work with those because it's really easy. Most of you know area formulas. Volume is a little bit harder, and that's what the EOC likes to give you problems on. So this is the definition for area, this is the definition for volume. Area is the amount of space that is inside a 2D object. That 2D is abbreviated for two-dimensional. Basically, if it can fit on paper, if you can draw it on paper, or you could cut it out, then it would be a two-dimensional object or shape. So like a square, rectangle, triangle, circle, all those are two-dimensional shapes. So that is the definition of area. The volume is the amount of space that is inside a 3D object or three-dimensional object or shape. So like a prism, like a box, a cube, a sphere, a cylinder, a can, like a vegetable can that you get from the store. All those are three-dimensional objects, and that's what you see more of than more so these are like paper, things that can fit on paper. These are actual things that you can hold. So those are the two formulas for area and volume. So we're going to practice with volume first. So these are some of the shapes. Prisms are a three-dimensional object where the two end faces are similar. Okay? So you have a 3D object. You can have a rectangular prism. You can have a triangular prism. The two end faces, the only criteria for it to be a prism is that the two end faces have to be similar. So right here I have a square or rectangle. I just drew the shape. So you can draw a shape if you need to. And then the two end faces are similar. So this one, the two end faces are a square. So the two end faces are similar. That's a prism. Now, if it's all sides that are square, we know that as a cube. And a cube is just side times side times side. That's easy. It's the same as finding the area of a square. It's just side times side. Cube is just three-dimensional. If it's not a cube, if it's a rectangle or a triangle, and it's called a rectangular prism and a triangular prism, this would be a rectangle or a triangle, and it would still extend out and have some depth to it. And each one of those would have a height, a width, and a length. So the volume formula for a prism would just be length times width times height. Okay, very easy, similar to the area formula of a square or rectangle, where we have length times width. Now we're just adding a third dimension to it and have a height multiplied to the end of that. Okay, so that is your prism's definition and formula. And if you need to draw that picture to remind yourself what it looks like, you can do that at the bottom of your little foldable, because you need to hold on to this foldable. We'll be using it a lot this week. All right, so that's a prism. The next shape we have a cylinder. Okay, cylinders are three-dimensional objects whose two end faces are circles or ovals. They can be ovals. Ovals are not perfectly round. You know what an oval looks like. So a cylinder. Some real-life examples, as I said earlier, you can go to the grocery store, get a can of corn or a can of green beans. That object would be a cylinder. Or like the inside of a toilet paper roll or tissue roll, that would be a cylinder because the two end faces are circles. So go ahead and draw your object here. The only difference here is that you have height. So you have two circles, and in between those two circles, you have some height or some depth into it. So that's the third dimension that makes this a 3D object. So the formula for a cylinder is just pi r squared, which would be the circle formula for area of a circle. And then we just add the height dimension into it to make it 3D. So we have pi r squared times height for the volume of a cylinder. Okay, so that is the definition and formula and picture for a cylinder. Very easy. If you know that the area formula for a circle, all you're doing is adding the height dimension to it. Okay, the next shape we have is a sphere. These are the first three easy ones. So sphere is the last one that you'll see a lot of. A sphere is a three-dimensional object where every point is equidistant. Some of you probably don't know what that word is. That's equidistant from the center. Basically that means equidistant is they all have the same distance from the center. Okay, so if I had, go ahead, you need to draw this picture. If you have the center point, which is right here, every point on the outside side of the sphere is going to be the same distance from that center. If it's not going to look perfectly round, and it's not going to be a sphere. So like a basketball, soccer ball, tennis ball, baseball, all those are spheres because every point is equidistant from the center. If it wasn't equidistant from the center, it wouldn't be a perfectly round ball to where you could bounce it, throw it, catch it, all that kind of stuff. Like a football. Football is not a sphere because it's not equidistant. The points on the end are not the same distance from the points on the sides where the laces are. So that is a definition of a sphere. The volume formula for that is 4/3 pi r cubed. Okay, so 4/3 pi r cubed. This r, I didn't talk about this in cylinder, r stands for the radius. So if you're going to have a radius given, that is half the distance going across. So if I had the whole distance, I'd have to split it in half to find that radius. Hopefully we know what radius is from 8th grade. So you just plug that radius in and cube it times pi and 4/3. So that's our definition, our formula, and a picture that you need to go along with it. And these are all going on your foldable here. Next shape that we have, and these last 2 or 3 I think are not very prevalent in what we'll be doing, but I'm going ahead and giving them to you so you can always pull out that foldable if you need to and look it up. Pyramid is a 3-dimensional object with a square base and triangular faces. So if you draw your picture, you're going to have a square base, and then they all meet at the vertex, which is at the top, and those faces form a triangle. Because when you're going up from each base, each vertex on the base, to the vertex at the top, you're going to form a triangle here. So it's a 3-dimensional object with a square base and triangular faces. Okay, and then basically it's the same formula for a prism. You're just taking 1/3 of it off. Because it's not, if you can look at it, you can probably fit this inside of a prism, but you're just chunking some of it off, and you're taking 1/3 of that, and that's what's left here. So you have 1/3 times length times width times height. And again, you would be given length times width and height, and you just take 1/3 of it, or divide it by 3, to get the volume for that pyramid. Okay, that one's very easy. We won't use it a whole lot, but you're just taking 1/3 of length times width times height. Okay, so definition, formula, picture, go ahead and draw that on there as well. I think the last one we have is a cone. A cone and pyramid are very similar. Okay, a cone is a 3-dimensional object with a circular base and lines going to the vertex. So here they don't have faces because it's going to form a circle on the base, so you can't have any sides off of this circle. So every line goes up to that vertex at the top. Okay, so you have a circular base and lines going to the top. This would be, an easy ice cream cone just flipped upside down. You can draw that picture here. Okay, so we have a center, we have the radius given, and if it's not given, if they give you the diameter, which you know what diameter is, you split that in half to get your radius. So you're going to plug that in for r. So your formula is 1/3 pi r squared times height. Okay, so you got 1/3, that's that 1/3 again, similar to the pyramid, because it's not a whole cylinder. And again, if you look, this is very similar to this is the cylinder formula, but you're just taking 1/3 of it because it's not a whole cylinder. Okay, so you got 1/3 pi r squared times height, and you have that third dimension. That right there, that height makes this a 3D object. Okay, so that is the definition, picture, and formula for a cylinder. Alright, so from there, we're going to do some examples given these shapes. And if you can't see this, this is a prism, rectangular prism. You got a rectangle on the front, and it just looks like a box. Go ahead and draw that shape. You have a width of 4, a height of 3, and a length of 5 inches, and those are all in inches. Okay. One thing that I'm going to be particular about when you're doing this is having your units labeled, okay, in your final answer. They'll probably give it to you in the initial problem like I have here, but in the end, you need to have your units labeled. Okay, so if you're given this prism, formula is length times width times height, very easy, you plug it in. 5 times 4 times 3. And I have inches here, so you can see that I have it written 3 times. So if your answer, once you do 5 times 4 times 3, you'll get 60. Then your answer, you have inches, so go ahead and write inches there, and just write, like the exponent, however many times you have inches written. That helps me remember, okay, that's 3 times I have it written, so I'm going to have inches cubed. Because volume is always going to have the cubed exponent at the very end. Okay, so to read that answer, my volume will be equal to 60 cubic inches, because your inches are cubed. Okay, you got 60 cubic inches is the answer given this length, width, and height of 5, 4, and 3. Very easy. Number 2, you have a cylinder here. Number 2, you go ahead and draw this picture. You got a circle at the top, circle on the bottom, height, and then I gave you the diameter. Okay, so this is the diameter. This diameter I have as 8 inches. My height is 12 inches. Now, diameter is not what's in my formula. If I look at my formula, I have pi r squared times height. That r stands for my radius. So if I'm given a diameter, I need to divide it into 2 to get my radius. So 8 divided by 2 is 4. That's what I'm going to plug in here for r. And then my 12, I'm just going to go ahead and plug in there as well. So plug those in. 4 squared is 16. 16 times 12 is 192. And I'm going to leave my pi because y'all don't have calculators in front of you. I'm not going to be picky about rounding and all that stuff. You can simply leave your answer 192 pi inches cubed, or cubic inches, because your dimension was inches here, or your units were inches. So you can have 192 pi cubic inches. That pi simply just is multiplying 192 times 3.14, all going on forever. But because you don't have calculators, just leave it there. Okay, so that is my volume for this cylinder, given the diameter of 8 inches and a height of 12 inches. You can see that you need to square your radius, and then you can simply leave your pi at the end of your number and have cubic inches there. Okay, so those are 2 examples. You got 2 more, and then you have a challenge word problem that I gave you, because that's what you're going to be doing with the classwork and any test questions you see. Okay, obviously you won't have these very easy ones like this, but you're seeing how to set it up and plug in the numbers here. Okay, so the next 2 shapes we have here are a sphere. So go ahead and draw a sphere here. And then I said r is equal to 3 centimeters. That r stands for radius. So you're going to have a radius of 3 centimeters. Once you draw your picture, go ahead and write your formula down. Your formula is 4/3 pi r cubed. This time I gave you r, so you don't have to divide anything by 2. I just simply gave this one to you. You're going to plug in that r to where r is. So you just substitute r for 3. So you have 4/3 pi 3 cubed. Okay, normally I would like to write parentheses around here. I did not do that. So when I substitute things, I like to do that. Didn't do it here. So you can do that if you want to. 3 cubed is 27. 3 times 3 times 3 is 27. Then again, I just multiply 27 times 4/3. Make that a common denominator, get the common denominator here, and just multiply across. Once you do that, you're going to end up with 36 pi. Again, I didn't multiply this pi because I don't have a calculator. I just plug it in on the end, and that will be okay. And then I was given centimeters, so I need my units labeled here. And again, I'm finding volume, so my exponent should be 3 because I'm finding the whole volume inside that object. So it's going to be to the 3rd dimension. That's a 3-dimensional object. Your exponent should always be 3. If it was a 2-dimensional object, your exponent would be 2. So volume is equal to 36 pi cubic centimeters. That is the volume of that particular sphere. All right, number 4, we got a cone. Cone is given with our base as a circle, all the points ending up to the vertex. This time I did give you the diameter. My diameter is 12 millimeters. Okay, millimeters are little tiny things on the ruler, and then my height was 6 millimeters. So I just started by writing my formula. What do I know? 1/3 pi r squared times height. Okay, if you know the cylinder formula, you're just taking 1/3 of it. Okay, if you can remember the cylinder formula, just take 1/3 of it, and then plug in what you know. Again, my diameter was 12, but there's no diameter in my original problem. So I need to divide my diameter by 2 to get my radius. So 12 divided by 2 is 6. That's what goes right here. Then I'm going to square that 6 and plug in my h, which was also 6 millimeters. Then 6 squared is 36. 6 times 6 times 1/3 is all going to be 72. And then I just plug my pi at the end of that. And then my units were millimeters, and I just cube them because this is a 3-dimensional object. So my final answer reads 72 pi cubic millimeters. Okay, 72 pi cubic millimeters. That is the volume for this whole cone. Alright, so those are 3 and 4. We got one more word problem that you will need to copy down in your notes. And this is a challenge problem. This is putting two volume formulas together to answer the question. So the question is, for Christmas, you want a new 42-inch flat screen TV. The TV comes in a box that is filled with styrofoam to protect it. The dimensions for the box are 50 inches by 6 inches by 30 inches. The dimensions for the TV are 40 inches by 4 inches by 25 inches. How much styrofoam in cubic inches is needed to protect the TV? Okay, so if you're reading this question, think about buying, and if you've ever bought a TV or any fragile object, around that object they normally put styrofoam or some type of protection. It might be that little popcorn stuff or little bubbles that you can pop. We're trying to find out how much of that styrofoam do they have in the box to protect that TV. So if I'm given the dimensions of the box, and I'm also given the dimensions of the TV, I could find how much empty space is left inside that box if the TV is inside that box. I can find how much empty space there is of styrofoam. Okay? So I've drawn two pictures. I would always suggest when you're given word problems, draw pictures of the shapes that you're given. Okay? I know the dimensions for the box. A box is a rectangular prism. So I drew my box here and just labeled the dimensions. So I had a 50 by 6 by 30. And then for the TV, I drew a TV over here, I had 40 by 4 by 25, and these are all in inches. Okay, so I'm simply just going to find, if I want to find how much space is in between, I'm going to be able to put this TV in this box but have space left over. I'm going to find the volume of this, find the volume of this, and find the difference. And difference is subtracting, so I'm just going to subtract the two volumes. So multiply 30 times 50 times 6, that came out to be 9,000 cubic inches. Okay? And then my volume for the TV was 4,000 cubic inches. Once I have those two volumes, you just find the difference. Because if this TV is sitting inside this box, I want to find the difference of how much styrofoam would be left over. So I had 9,000 minus 4,000 to give me 5,000 cubic inches. And that's the amount of styrofoam. And that simply answered my question. If you were annotating this whole thing, which I did not do, you would just annotate the last part, which is always the question. How much styrofoam in cubic inches is needed to protect the TV? Okay, this is a real life problem that you would be able to solve given a box or given the TV inside the box. You could find out how much styrofoam was really there. Okay, so I just simply subtracted my two volumes from each other to find that difference, and that's how much is left over. So that is using your formulas to answer a real life problem. And given your rectangular prisms in both, you just simply multiply them all together to get your volume and then subtracted them to find the amount of styrofoam. So that is volume. We'll deal more with area as we go along because area is very easy. Volume is the harder part because you have fractions in your formulas. I wanted you to get introduced to that first. So those are your notes on volume and area.